Alright, let's look at the first example problem in chapter 14. We've got a mass on an inclined plane with no friction, and it's already stretched. The spring is already stretched 0.5 meters. So it would require some force or a lot of friction to keep it in place, but we also have this force P pushing horizontally to the left, and it's got a magnitude of 400 newtons. That force pushes the block 2 meters up the frictionless plane, and they want us to find the total work. But we're going to find it in individual pieces. We'll find the work done by each force. So let's start off by making a free body diagram. Well, there's our incline, and here's our mass. We're going to have mg pointed down. We have a normal force pointed perpendicular to the plane. We have a force P being applied horizontally, and the spring force pointed back down the plane, because as we push it up the plane, the spring is stretching more and pulling us back down. Okay, so let's look at the work done by the force P. We have a 400 Newton force, and it's acting in the displacement in the direction of 2 cosine 30. So it goes 2 meters up the incline. We need the component in the direction of the force P, so that gives us the 2 cosine 30. And we get 692.8 joules. Alright, hold on to that. What about the spring force? The work done by the spring force. Well, we have a formula for that. We say it's 1/2. We take the spring constant, and then we take our final position. So it was initially stretched 0.5, and we add 2 meters to that to get 2.5 meters. Don't forget to square it. We have a minus sign with another 1/2 times 30, and then our initial position, which is 0.5, our initial stretch, which is 0.5. Alright, crank the handle on that. You see we get a negative 90 joules. It is, you'll see that we can relate energy or the change in energy to motion. The spring is actually going to be slowing us down, so it's removing energy from the system. That's a way I like to think about it. What about the work of the weight mg? Well, it's the force times the displacement. Our displacement is this delta y right here, and we can say that is equal to 2 times the sine of 30. So I get mass times gravity pointed down, and our displacement is a 2 meters times the sine of 30 degrees, giving me a negative 98.1 joules. The weight acts in the opposite sense to its vertical displacement, so the work is negative. What else do we got? We've taken care of the spring force, the force P, the weight. I guess we've got the normal force still. Now, does the normal force do work? 5, 4, 3, 2, 1. No, it doesn't, because the displacement is up the plane and the normal force is perpendicular, and we learned if the angle is equal to 90 degrees between the force and displacement, then no work is done. Okay, so all we need to do is add up all our different components of work. We have the total work as 692 minus the 90 joules from the spring minus 98.1. Those are all in joules. We're going to get 505 joules as the total work acting on the block to get it from point A to point B, or its initial position to its final position.